we are lucky to have visiting speaker here today, Second Lang. He's an English astronomer, as he likes to call himself, and has had a tenure in the IT industry, a long career in IBM. But then he has also been very actively pursuing his favorite amateur astronomy activity, which is asteroid study of asteroid occultations. And that brings him here to India. In fact, there was an asteroid which was just crossing from us now, and the resulting shadow was to cross over Pune just yesterday. Of course, there was shadow of the tools that he missed out on that. You can see the effort he has taken. He has stored a lot of equipment, and the whole team is ready yesterday. We faced disappointment. But making best use of his time, he has also given a talk on Saturday on space pizza or food in space. This was from Yamachi. Today he is presents to us art in space in space now. Quick few words about him. So he's been a long part of his life has been in the northeast of USA. Now he shifted because the rights to the southwest to Arizona. He's set up his own observatory there, and he's also helping a group called the International Observation Timing Association. He's also an NASA Space Ambassador, who does a lot of outreach in his country and around the world. So we're very fortunate to have you here, and please, you can have.
Thank you very much. Thanks, Spirit. I hope everyone hear me okay. Thank you. Well, it's nice to be here. And since I've been here now for about 8 days, it's also very nice to be awake in the afternoon. It takes a little while to adjust. I'll be going home tomorrow, and of course, then I'll have another 8 days to adjust to Arizona time, which no problem. I've enjoyed it here. It's been a fantastic trip. As Samir mentioned, I gave a talk the other day on we called zero gravity pizza. That was for the children who came last Saturday. We talked about food that's eaten on the International Space Station, and we talked about Shivansha Shukla, who the Indian astronaut who went to the space station and brought along some Indian food, gajar al halwa, right? And thank you for ordering that last night at dinner for dessert, so I can taste what they ate in space. It was delicious. So today I will speak to you as someone with absolutely no artistic talent at all. Anyone in the audience who can draw a circle on a piece of paper has more artistic talent than I do. But I will make an attempt to join you in a trip to places where only an artist can take us. Places where we can't go and things we can't see, but things that an artist can draw or paint or sketch or image that will give us the opportunity to travel through space and sometimes even through time using the eyes of the artist. So the first thing I want to talk about is a distant planetary system called TRAPPIST-1. It's a red dwarf star that's about 40 light years away, and it's in the constellation, the direction of the constellation Aquarius. And this, until we had some artistic views of what the planets around this star would look like, this was the best image we had of planets TRAPPIST. So what are these lines? These lines represent the light intensity from the star, which would be up here, but reduced slightly when one of the 7 planets in orbit around the star happens to pass in front of the star, between the star and Earth. So we can actually confirm the existence of exoplanets by measuring the light from the star and measuring the tiny drop in light intensity as the planets go in front of the star. We've got 7 planets. So this is the best picture we can get of this star, the planet system around this star, till an artist comes along and tries to give us a slightly better image of that using artistic talent and virtual reality. So let's take a look at what an artist in NASA thinks those 7 planets might look like. So you are now 40 light years out into space, looking at from the closest planet to TRAPPIST-1, one by one at these 7 planets that are going out into space. And you might notice that when we get to planets number 3 and 4, they start to look a little bit more maybe like Earth. These might be the planets that are in the Goldilocks zone, the zone where the temperature is such that liquid water could exist. And if liquid water can exist, then maybe life can exist. The other thing to notice, I don't know if any of you are amateur astronomers, but you might notice some constellations going by in the background. So there's Orion, but you notice the stars in Orion's belt are not in a straight line anymore. We've gone out 40 light years, and now the perspective towards the stars in Orion has changed. So we know that those stars in Orion are not exactly the same distance from Earth. And so those are the 7 planets there. And that's how the general culture majority of that. So art and face in art, I've divided it up into kind of these 6 categories. The first one is what you just saw there, where the artist or scientist is attempting to be as accurate as possible, understanding the constraints that we don't know much about the planets, but we know what planets must look like. You know, they should be round if they're a certain size, they should have water on them if they're in the right temperature range, and so on. But we're not limited to accurate artistic interpretations there. We have cosmic impressionism, so that means let your imagination run wild. Character art, which I love, that's just people who love making pictures or images of space hardware or electronics hardware, because those are electronic devices that even the ones that I've been looking at, those are pieces of art in addition to being pieces of electronics. And so I appreciate the artistic view of those as well as the electronic and mechanical components of those as well. Space sculpture, of course, 3D depictions where you actually make something. I don't have any pictures of alien life in alien settings, but if you ever want to watch the movie Alien, you can see all the aliens you want. I'm not interested in showing you those. But of course, we also have astrophotography. And that's where you have a blend of the technical and the artistic or the aesthetic. And most of the astrophotographers that I know attempt to make their pictures as beautiful as possible, in addition to being scientifically accurate. There's nothing wrong with making a picture artistically beautiful. So, but some of the best artists and most creative artists are the children. And every year in our town in Arizona, we host a Dark Sky Festival. And the Dark Sky Festival includes a art contest for students in our schools in the Fountain Hills, where I live. We have a big fountain in the middle of Fountain Hills. It's what gave us our name. For a while, it was the tallest fountain in the world. It went up 500 meters when all the pumps were running. We only use 2 meters now to save them. They're 50 years old. They're still running, so we're very happy about that. But you can see some of the artistic creations of the students here, and we give them a theme every year. So I think this year's theme was preserve the dark skies. Okay, and that's all we told them. And then they went and created this stuff. And some of our students also were, I think, extremely creative. And this came from somebody who was 6 years old. And I won't be surprised if this person ends up working here at IUCAA someday, because I love this level of imagination. Here's Earth, we've got a spaceman out in space, and of course he's smiling, which is great. There's stars, there's planets, there's black holes, there's galaxies and Saturn and everything else. I can't imagine the skill of somebody who's able to do that. But these are the kinds of pictures that got me interested in doing this presentation. When I was younger, I used to love to read science fiction, and it was published in these magazines, these soft magazines, paperback. science fiction magazines. Galaxy, Asimov, science fiction. Some of you probably grew up reading the same things, maybe digitally, maybe for real. But the cover always had one of these incredible pictures up, where some artist attempted to kind of, well, first of all, to get you to buy the magazine, but second, to give you some idea of what it might look like to live on a planet and float in space or something like that. But then some of these paintings and images were actually commissioned by NASA and by the government. This one is done by an artist named Chesley Bonestell, and he was one of the most prolific artists in the sense of covers of magazines and things like this. And this was commissioned by Wilhelm Röhm in 1952 to try to get money to build a space station that would have artificial gravity by being spun in space. It would make it very difficult to dock with the station, of course, if it's spinning, unless you docked at one of these access ports here. But look down here, there's a couple of astronauts in spacesuits working on the space station, and you better hope they're holding on tight if this thing is spinning around, because otherwise they're going off into space and never come back. So that wasn't built, but that was basically commissioned in order to try to get government money to build something which today we know is the ISS. This magazine cover from Asimov Science Fiction represents what the artist was trying to call a cosmic Christmas. So here's a family in spacesuits on a moon, probably maybe a moon of Jupiter, celebrating Christmas there. You see they put a little Christmas wreath on top of this big rock here. In an attempt to, I guess, remind them that they're far from home and they miss all their holidays and everything. But maybe someday on Mars, the entire family will live like this. But until you see a picture like this, you don't really begin to understand the sacrifice that a family like this would have to make to go live on a moon of Jupiter, right? Here they are, they have to live in spacesuits all the time. There looks like there's plenty of gravity on this tiny moon. It seems to me that if it was that small, they would probably just float off into space, but that's artistic license and that's fine. I talked about astroimaging, and astroimaging is a way to get accurate images of what's in space, but some of my friends also take a pencil and a piece of paper and they do their best to sketch what they see in the eyepiece. And to me, this is the only way that I can begin to imagine what they're seeing in their own mind when they look through the eyepiece. I know what I see, and you can describe to me what you see when you look at Andromeda or something in the eyepiece. But when somebody takes the trouble to take a pencil and spend several hours sketching out exactly what they see, then that's sort of an invitation, a window into what's inside their mind, how they perceive this. And that's comforting because it makes a nice connection between that person and everybody else who does amateur observing. You know, if you look at this and you say, yeah, that's pretty much what I see when I look through an eyepiece at Andromeda or some other galaxy. It makes a nice connection among the community of amateur astronomers. Do we have anyone here who's an amateur astronomer? Have your own telescope, look through things? A bunch, good. Well, I think he did a great job. Here's a photograph from the star system of Andromeda. And so when I compare his image with the picture, you notice many things are the same, but it's interesting that he felt like the stars in the foreground deserve a little more emphasis than we see in a photograph. The dust lanes in the galaxy are more intense in his photograph. So this is a suggestion of what he's actually seeing and perceiving in his own mind, that there's no other way that I can't telepathically connect to somebody's brain. If someone takes the trouble to do something like this, it helps all of us understand how they perceive what they're seeing in the eyepiece. And that kind of communication between people is very reassuring and comforting. Here's a picture of the moon that I took with my cell phone through an eyepiece of a small 80 millimeter refractor telescope. And you can see the terminator here. So of course, the sun is shining on the moon from here on the left, and that makes all of the craters near the terminator in three-dimensional relief. You can see the walls of the craters lit up here. I don't even have those rebound mountains inside. There's one here and one here and so on. But I want to compare this with our friend Galileo Galilei, right, in 1610, who published the book Sidereus Nuncius, the Starry Messenger, about all the exciting discoveries he had made with his brand new telescope. And of course, the primary objective lens of his telescope was probably the size of a lentil, the size of a centimeter, maybe. He grown it himself. And the eyepiece lens was probably the size of a tiny lentil or pea. But he made all those fantastic discoveries, the phases of Jupiter, craters on the moon, the phases of Venus, craters on the moon, the moons of Jupiter, 7 PhD discoveries in 6 months, right? And published this book, which we know kind of got him in trouble. But as an artist, I just wanted to give you an idea of just what a good job he did sketching the big Maria on the moon. He had no idea what they were, but you can see he did a great job of identifying for us what the moon's features looked like, and understanding that the moon was not completely smooth like everyone thought at the time. It was a perfect heavenly object with no imperfections on it at all. And Galileo explained to everyone, not to everyone's satisfaction, but he made it clear that the moon was not this perfect billiard ball of smoothness, but in fact a rocky object body like Earth with imperfections, mountains, depressions, and craters and things like that. So great job for Galileo, for all of us. In 1875, another French artist made a sketch of Jupiter through a telescope as well. And you can see most of the features of Jupiter that we know about today. We compare it with our Hubble telescope image today. Again, the main features are here. The eye of the observer emphasizes certain features and de-emphasizes others. But he did a great job of attempting to explain that there's more going on Jupiter than you might expect looking at it naked eye. So you can see many of the details, the great red spot, and that's been there since Galileo looked at Jupiter, and for 400 years, and we still don't quite understand what's making it grow. But Jupiter's got cloud bands, equatorial cloud bands on it, these spots that move around, and I think that might even be the shadow of one of Jupiter's moons, like Titan, that you might have seen. We just had a Titan shadow cast just the other day, and the last one for several years. That was imaged by some friends of mine as well. This is a poster for the movie 2001: A Space Odyssey. Anybody seen that? That's a classic, right? That's with the big black monolith on the moon, and yeah. Here are the Earthlings heading off to Jupiter to figure out why the monolith is present on the moon, and so on and so forth, and all of our astronauts here. But does this little tablet with a keypad on it remind you of anything in particular? Could it possibly have been part of the inspiration for the iPad? The tablet could do what was right. But here it is. It's sitting right here in Steve Jobs' lap. And here it is in 2001: A Space Odyssey movie poster. Maybe not a coincidence. This is a picture I took of the launch of the shuttle Atlantis. This was the final shuttle launch. And like an idiot, I thought the shuttle launches would go on forever. So I never went to Florida to see one until the very last one. And then I had to spend 8 hours on the computer trying to get a ticket, and finally got through and managed to show up and take a bus ride and all that stuff. And this launched right on time. So there were no weather delays, thank goodness. So in an image that I took, I think we're about 5 miles away. The sound hasn't even arrived yet. Shuttle here, the external tank and solid rocket boosters, and so on. But when an artist takes a look at this, here's an artist picture by Greg Moore. This several of the pictures I'll show today are part of what we call the NASA art collection. So NASA has actually invested in some artists to document the space program and different components of it. So this is one of those images, and you can see that the artist in this case, I think really emphasizes the brilliance of that flame. I mean, I knew it was bright, but of course it's in a rather bright sky, but darkening the sky really emphasizes this, and there's much. It was in front of a puddle of water, so there's much more of that beautiful reflection of the exhaust plume in there. So again, just a more colorful image reflecting how one person's mind perceives something that I might see completely differently. I have a friend in New Hampshire, Jennifer Ben, who works on large-scale images of space art. And this is 2 meters tall, and she calls it night launch. And this is a image that she painted of a night launch of the space shuttle, showing a long exhaust plume and her own personal artistic interpretation of what that highly engineered scene looks like. When I look at that, I think of chamber pressure and exhaust plume velocity and things like that. But when an artist looks at a launch like that, they see something in a completely different vocabulary that I don't speak. But to look at this invites me to become a member of the community of people that think and speak like the artist. It's kind of there opening the door a little bit. Come into my mind and share what I see when I look at things like this. So it's a nice invitation. And here's a couple more images that Jennifer created. This one is another 2 meter tall image, and I've seen a few of these in person in museums and at her home. And they are more impressive in person. I can tell you that they are here. There's something about the surface of a real oil painting that just gives it that look of being alive. Another image from the NASA collection here. Again, this is an image of the shuttle before it was ready to launch, sitting on the pad, and you can see everything's peaceful, birds flying around. They don't know that a big noisy event is about to happen, and eventually that device will up into space. And other than the 2 sad occurrences of Challenger and Columbia, every one of the shuttles would come back home, fly to landing either in Florida or at Vandenberg Air Force Base in California. And if it went to Vandenberg, then of course the shuttle had to be carried back to Florida on the back of a giant 747. I've never seen that happen, but I've seen images of it and videos of that. It's fascinating. But this is an unpowered descent, and the landing gear doesn't drop until the shuttle is about 25 feet above the runway, and that's like 3 seconds before touchdown. And so, and that's the only part of the landing, I was told, that can't be controlled by the computer, because if the computer, if the landing gear doors were to open in space, there's no way to close them, and there's no way for the shuttle to survive re-entry. So the astronauts have to actually push them up to make the landing gear drop in the space shuttle, to ensure that no matter how good the programmers are, I was a good programmer, but I wouldn't trust myself to be that good to make sure that those wheels didn't open until you were ready to touch down to the desert. Now the sun casts shadows, of everything on Earth. There's a shadow of a nice tree in the desert. But the sun also casts a shadow in space, the shadow of our planet Earth. Shadow goes out into space. You're all familiar with the umbra and penumbra of the Earth's shadow out into space. And if the moon happens to cross our shadow, we have what we call a lunar eclipse. So I took some photographs of the moon as it passed through Earth's shadow, and I just want to point out that images like this that are considered scientific images or artistic photographs can also be educational and scientific as well. Here you can see immediately that the Earth's shadow on the moon is curved. And for thousands of years, Indian astronomers, Arab astronomers, Greek astronomers all use this as evidence that the Earth must be round as opposed to flat. because we cast a round shadow on the moon during a lunar eclipse. There are many thousands of lunar eclipses over recorded history that could be observed. But it turns out also that if you put these three pictures into PowerPoint and just add a circle, and you try to line the circle up with these curves, you get an estimate of how big Earth's shadow is out in space at the distance of 240,000 miles where the moon orbits. So we can take an image that we think is simply artistic and beautiful, and we can learn something scientific from it as well. And when I first did this, I was amazed at how large Earth's shadow is. That the orbital shadow, the central part of our shadow, there's much larger penumbral shadow, of course, down here. But this was a surprise to me. It's almost 4 moon diameters across at the middle. And when the moon happens to pass right through the center of Earth's shadow, that's when we get the very, very dark red moon from the point where the moon is dead center in the orbital shadow. And because that happens only rarely, this artist, Lucien Rideau, painted this picture of what it would look like from the moon if you were looking back at Earth during a lunar eclipse. So in this case, the sun is on the far side of Earth. And here you can see the red ring of refracted sunlight, mostly the red light. The blue light tends to be scattered off into space, and the red light gets refracted around the moon and follows around the Earth and causes the moon to look red in the shadow. So here's what the red moon would look like if you were standing on the moon during a lunar eclipse. Instead of bright white sunlight, you'd be seeing this refracted red light. So this is basically all of the sunsets everywhere on Earth seen at once at the same time. Beautiful. And of course, there are other kinds of artistic views of the moon that are less sanguine and more dramatic than this. And hopefully, that was not. Here's an image of one of our astronauts standing on the landing pad of the lunar module. We know that this descent engine brought the astronauts safely down to the surface of the moon. All the fuel and oxygen and water supplies were carried here in the descent stage. And then this little motel room up here with its own rocket engine was where the astronauts lived. And then eventually this part would separate and fly back up into space to rejoin the command module and bring everyone back home to Earth. So this is a photograph of that. But as soon as that happened, Norman Rockwell, famous artist, was commissioned to do a painting of this event, or one just like it, for Life magazine and magazine, and he did that in December of 1969, just a few months after the landing, showing in this case Neil Armstrong, the first person on the moon, taking a photograph of Buzz Aldrin descending on the ladder from the lunar module, and he got this right. There's a shock absorber inside this leg that would collapse. There was a single-use shock absorber just made of some foil, so that if they landed hard, they would absorb the shock and not damage the interior. But Neil Armstrong landed so carefully that there was no actual compression of the shock absorbers, and so all the astronauts had to leap off the bottom step of the ladder to get down to the moon, and they had to jump back up and to get back into the lunar module. That was a surprise to everyone. And there's another Norman Rockwell painting of the same thing, astronauts taking the first step on the moon. We have photographs of this, but Rockwell emphasizes the fact that this engine shot dust out in all directions. And you might remember Neil Armstrong pointing out that at a certain level of descent, he could no longer see the ground. It was completely obscured by the dust being blown away by the engine. And so actually every one of the landings on the moon had to be landed blind for the last few feet, just to make sure there are no big rocks there, and then head on down. It's like instrument flying if you're a pilot. Now, Alan Bean was an astronaut on Apollo 12, the second landing on the moon. And you probably remember that Alan Bean dedicated the rest of his life to being an artist and to try to recreate the images that he remembered seeing while he was in space, and some of the ones that didn't actually happen or that happened to other astronauts as well. He was a very, very accomplished artist, and you can see him here in his studio with his own work. And he had a very unique style that I think lended itself well to such things like this. So here he is. He's a young man next to a mock-up of the lunar module, and here he painted what he imagined he would look like as his first step on the moon. He was pretty short, and it was a big jump to come down from this ladder. So this is his view, his version of what he thought it would look like for himself being on the moon and taking that first step on the moon. Now, Apollo 12 was, well, I should go back. Apollo 11 landed about 5 miles away from the landing site that they were supposed to land at. This was a big problem because the geologists had calculated, had given them all kinds of instructions to go to various craters and gather rocks at the rim of the craters, the bottom of the craters, and so on. And now they were nowhere near the craters they were supposed to land near. So they had to improvise all of their scientific investigations. So the NASA brass said, no more. Figure out a way to land accurately on the moon. So they did that. They did that using radar reflectivity, Doppler changes in the frequency of radio, and so on. So they knew exactly where they were. But how do you know? How can you prove you landed where you were told to land? The way they proved it was by saying, okay, 18 months ago, the Surveyor spacecraft landed on the moon. Why don't you guys make sure you land within walking distance of the Surveyor spacecraft and bring back some pieces? So that was the target. And sure enough, there's the lunar module right here on the rim of Surveyor Crater. And here is, I think this is, can't remember which astronaut it is, actually on the moon, removing some of the, so this is the camera with a little a mirror on top of it so that the camera can take pictures at different elevations. And it turned out that in 18 months in space, there were bacteria that had survived on that camera structure that then grew on Earth after they were brought back to Earth. But you can kind of see a little bit of a reflection of the Surveyor in the helmet visor. Here it is right here. You can see that. And so Alan Bean decided he would make a painting of something like that. And so this is Alan Bean's version of that, where you can see the Surveyor that they actually visited reflected in both of their things. And what did he call this? Please take me back home, guys. So the Surveyor wanted to come back home. I totally understand that.
So in the original, that was actual photography.
I'm sorry?
The previous one.
Oh, okay.
No, yeah.
Yeah.
It is actual photography.
Okay, so yeah, this one is an actual photograph taken by Alan Bean of, I think it was Dick Gordon, in his spacesuit, removing some parts from the Surveyor. So this is an actual photograph of them on the moon. The Surveyor crater looked pretty steep, but it was big enough that they were actually able to walk safely down the inner wall of the crater and get to the Surveyor and remove some pieces to bring them home. So that's an actual photograph of it. And in this photograph, you can actually see the reflection of the spacecraft sitting on the ground in the visor of the spacecraft. And so when Alan Bean made that, he decided to, instead of replicating that photograph, he decided to do it from a different perspective of the spacecraft looking up at the two astronauts and imagining that the spacecraft could be saying, hey, how about I can hitch a ride home with you guys? It's cold up here. I'm driving home. So that's kind of neat. And here's another image of him, shaking hands with the arm that was used for soil samples, to dig up soil samples out of the crater as well. So again, there was no one on the moon to take this photograph. So Alan Bean recreated this photograph out of his own memory and what he thought it must have looked like if there had been a third astronaut on the moon taking photographs or sketches of that as well. And finally, remember in the Apollo program, only 2 of the 3 astronauts in the Apollo command module got to go down to the moon. The third astronaut stayed in orbit, and that was Dick Gordon. And so what he wrote here, he called this one the fantasy, where all 3 of the astronauts got to go down to the moon together. And everyone got to experience what it was like to be on the moon. Clearly something that never happened. There were never more than 2 people on the moon at the same time. But this way, he gave his friend kind of the opportunity to imagine what it would look like if he go down to the moon. I don't believe Dick Gordon ever got to actually go to land on the moon after all that. And there is art on the moon. This tiny little art chip contains sketches by these 6 artists. It was commissioned by some of the engineers working on the lunar module, and they hid this on the lunar module. So this is, as far as we know, this is the first piece of actual space art in space. That's how I could call my presentation, space art and art in space, because this little chip, tiny little chip, 19 by 13 millimeters, you can imagine which one of those diagrams was done by Andy Warhol, I'm sure. No surprise there. And when 1902, George Méliès decided that the way to get to the moon would be to put people inside of a giant bullet and launch them out of a cannon. This was how you got there and landed safely. Okay, the next few pictures are from an artist named Scott Listfield. And Scott Listfield, for some reason, decides to put an astronaut facing away from him in every one of his artistic paintings. And so he's got this one called Eclipse, where the astronaut is watching an eclipse, obviously a fantasy of some kind as well. Here's one called Longhorns, where we've got probably this might even be imagining the VLA array, radio telescopes, or some other somewhere. Naturally, there'd be cows walking around, but there probably would be astronauts walking around in the field as well. And for some reason, he likes Waffle House. Anybody been to the US and eaten at a Waffle House? Okay, these are classic, cheap, sticky floor places to go and get breakfast in a hurry. And if you don't know what a waffle is, just in case that makes you hungry, waffle houses have the honor of saying, even in a hurricane, we never close. So in Florida, where they have worst hurricanes and cyclones on the planet, just like you have here, you can always go to Waffle House. And if Waffle House closes, then it's time to evacuate. Here's one again. Fantasy pictures, images like this. He's still very active. He's still painting. He still has shows, and he sells his artwork as well. And here's his website in case anybody's interested in looking at this as well. If we go back to Gemini 4 in 1965, the Gemini program preceded the Apollo program. The Gemini program was important to prove that we could do certain things in space that were needed in the Apollo. There were 2 important things. One was rendezvous between 2 objects in space, which turned out to be really much more difficult than anyone ever imagined. And the other one was to walk in space, to do a spacewalk, an EVA, extravehicular activity in your spacesuit. So here's Lynn White, who tragically died in the Apollo 1 fire, you might remember, a couple years later. But he's out in space, and he's connected by this 25-foot umbilical cord, and he's got a little nitrogen thruster, which he thought was going to make it easy to navigate around in space. But if you've ever seen the movie Gravity, where Sandra Bullock tries to do the same thing with a fire extinguisher, you know that's quite difficult. Obviously, to have all you engineers, to have the thrust going right through the center of mass is very important in rocketry. Okay, enough science. That's really hard to do. And if you don't do it just right, all you do is spin around in a circle. And that's what happened to him. So my friend Jennifer Ben tried to imagine what that would look like with two astronauts out there trying to connect up with each other, connected by umbilical cords, getting all wrapped up, basically suggesting this is not an easy thing. Moving in space is difficult, and here's an artist's interpretation of what it would look like if you got into big trouble outside of your spaceship. I don't know how you would ever get untangled from this. So Jennifer did that. Another image from Jennifer, basically contrasting the quietness before launch with the incredible energy and adrenaline rush of launching a spaceship into space as well. And just another painting of one of the next planes flying at Mach 2 in the sunset. I don't think this ever actually happened, but again, an artist saying this looked at dawn. This might have looked like against beautiful dawn, sunrise sky. Another image of the space shuttle from the NASA art collection as well. And another image from the NASA art collection of an astronaut with a large backpack that does a good job of giving you maneuverability in space with the nitrogen thrusters, oxygen and water supply, and so on. But obviously, with the Milky Way in the back, all those beautiful stars, it would be very hard to get a photograph like this because in order to expose for all these stars, this astronaut would probably be totally overexposed. But the magic of an artist can take care of that without worrying about CCD and exposures and things. There are other stars that we know have planets. In fact, as far as I know now, it is thought that we have more planets in the universe than we have stars. The average star has more than 2 planets around it. And so there's no shortage of places where life could exist, might exist. We don't know if it does, of course. But if you were on a planet around 3C667cc right here, on a moon of that planet, we think that planet has water on it. It might be green or blue, and this is what it might look like. So, rocky. I'm not sure where you'd be living or where you pitch your tent. It would be hard to pound the stakes in for sure. Now, if we go to the Galileo mission was launched towards Jupiter to study Jupiter, went into orbit around Jupiter, but it also had attached to it a probe that was released from the spacecraft and parachuted down into Jupiter's atmosphere to learn about the layers of the atmosphere while the main spacecraft went into orbit around Jupiter. We could never be there to see that, but here's an artist's interpretation of what that might have looked like if you were standing right next to that spacecraft at the moment after this probe was released. The other thing that's fantasy about this is that the Galileo antenna is fully deployed. You might remember that the Galileo antenna never fully deployed because the lubrication fell off during the delay of launch. I guess it was some sort of powdered graphite. And when they tried to open it, it didn't open. So they had to use the low gain antenna for all the science. They managed to recover most of the science by recording things on the tape recorder and playing it back at low bit rates, but it was quite a challenge. So it would have been great if the main antenna had opened. The only place it opened up was in this picture, sadly. And here's another painting of what might have looked like if you were flying around in Jupiter's atmosphere and watched the Galileo probe drift on by on its parachute as in down to the level of being crushed by the atmospheric pressure and temperature of the bottom parts of Jupiter's atmosphere. Again, something you and I would never be able to experience directly. Here's a picture of M81, Bogey's galaxy. It's we know lots about this galaxy, right? It's 12 million light years away. We've got older redder stars in the middle, yellow and blue stars in the outer edges as well. But what we don't know is what it might look like if you were a little bit closer. Not that many millions of light years away, but who knows how close there. Possibly on a planet in the outer fringes of that galaxy, and this might be in your sky every night. Wouldn't that be amazing? I would certainly love to see that. And of course, artists can also imagine things that we wouldn't want to be around for, like the Cretaceous Tertiary extinction event with a giant asteroid destroying most of the life. There are some pterodactyls who just haven't gotten the news yet that the parties will. Here's a picture of Saturn from the Cassini spacecraft in orbit over Saturn's, I believe, North Pole. Yeah, you can see the polar hexagon here. Somebody once tried to explain to me how a brown planet spinning can end up with a six-sided cloud structure. The physics works, I guess, but it's not something that I can easily understand. But anyway, but if you wanted to imagine what it would be like to float down somewhere near Saturn's rings, this might be what you would see. The rings are made up of billions of chunks of ice and rock, and the rings are only, what, 50 or 60 feet thick, and they're 250,000 miles across. If you brought Saturn into the space between Earth and the moon, and these rings were solid, you could jump on these rings like at the airport people mover, ride them all the way around, and step right off on the moon. The rings would stretch all the way from Earth to the moon. But this is what they would look like. So that would, because they're not a solid surface, they're made up of billions and billions of little chunks of ice. Back in 1870, William Parsons in Ireland, even though the weather in Ireland is terrible, managed to build the largest telescope on the planet. This, to me, now I don't think you would want to grind a telescope mirror that big. I think it was about 8 feet across, and it was made of speculum metal. So they had to polish it constantly to eliminate all the dirt on it. But this is what he sketched for an M51 galaxy. And what you might not know is that that picture made it into an astronomy book. This sketch right here made it into an astronomy book. And that astronomy book made it to an insane asylum in the south of France. And permitted in that insane asylum was a young artist. And that young artist painted this picture, Starry Night, right? Vincent van Gogh. After he cut off his own ear, he committed himself to this asylum, and it is now fairly well believed that it was his view of this image in that astronomy book that inspired him to paint the picture Starry Night that we all know and love so much. And here's a comparison of William Parsons' sketch of M51, the Whirlpool Galaxy, with recent Hubble Space Telescope image of it. Not a bad job at all. Not a bad job at all. Another Alan Bean image. This is a photograph of I think it was the Apollo 16 astronauts. Remember, the last 3 Apollo missions had a little car to drive around to cover more real estate on the moon, and the astronauts were able to visit places much farther from the lunar module than when they had to walk. So this is a photograph of these astronauts near the giant rock, basically the size of my house. And Alan Bean decided to make a painting of that image, reflecting a little more of the detail. But here you can see the astronauts. There's this little car was actually able to fold up inside the bottom of the lunar module. And in order to get it out, they just pulled a rope, and the car unfolded itself and set itself down on the ground, ready to drive away. It was an absolutely amazing engineering feat, and it was a big rush job. And General Motors and Ford and a bunch of other companies donated a lot of time and people effort to make that possible. So here's Alan Bean's interpretation of that. Getting close to the end here, you probably all recognize this as Earthrise photo. This was taken on Apollo 8. Apollo 8 was launched to the moon when the lunar module, which was supposed to be ready for a mission to the moon, was not ready. And so the planners said, well, maybe we can just send the command module to the moon, get it into orbit, and make sure we can do that part. And we'll worry about the lunar module part on the next flight. So Apollo 8 went to the moon, and you might remember that Bill Anders took this photograph when he saw the Earth rising up over the edge of the moon. He said, "Give me the camera." And Jim Lovell, the commander who just passed away, he said, "Don't fool around with that stuff. We have work to do. There's a plan." And Anders said, "The heck with the plan. Give me the camera." And he took probably the most famous photograph and the one that basically inspired the environmental movement by pointing out that we have this pale blue marble, and that's where we live. And Alan Bean designed and painted that image, which he called the source of intelligent life. Right? His version of the Earthrise photograph from Apollo 17. So I'll close with a photograph that you all recognize, a picture of our country here, and to just want to thank you all for your attention, and I appreciate you coming to this talk.
Thank you so much, Dick. We have a few minutes in case you want to have a conversation or a few questions. Yeah, Seam went first. Okay.
It's just curious. So the mission by NASA, do they have any scientific background?
So the question is, do the artists commissioned by NASA have any scientific background? I imagine some of them might, but to be honest, we don't know any of them personally, so I can't be sure. It would be hard to believe they had none. At least they should be interested in this direction. But as far as being scientists or engineers, I'm not sure. Yeah, good question though. Sorry. Yes.
Slide 1875, I think, on the picture. There is two white spots. What are the one you said could be a whole like person.
Oh, yeah, I'm not sure. And we go ahead and to the moon's photograph. Yeah, it's far back, isn't it? Yeah, that was one of the early photos, right? I should have gone back to the beginning of the presentation, but anyway, we're going to see the pictures again. So this one from Jupiter, yeah. Yeah, I would have to believe that these white dots are probably some of the white clouds that you can still see on Jupiter today in telescopes. For not all of Jupiter's clouds are colorful. There are still some white cyclones that somehow pop up and are visible in photographs and even naked eye. So I'm not surprised that there were some white dots in the sketch from 1875. But I don't know exactly what they would have been. We don't know what hour that was. He took that sketch because Jupiter rotates in just 10 hours, so things move across Jupiter very quickly. And 5 hours later, those dots would have been on the other side of the planet and invisible. But I'm not. Yeah, you can see some white dots even in the photograph that Hubble took as well. Yes.
Kind of stimulus these artists got by looking at these astronomical or aeronautical images. Something similar in other disciplines like biology or oceanography.
Okay, so the question is about other fields like oceanography and biology, and yes, there are some really amazingly good scientific illustrators illustrating things like cell division and DNA replication that are done in such a way that someone who's interested in the details of the process can see many of the steps in the process of the DNA molecule separating and the chromosomes and recreating the new DNA strands and so on. So yeah, there's all that, and there's also a movie that I saw when I was in college that showed the Stanford marching band showing how DNA replication works. And so they marched around on the field and showed how a strand of DNA would come in and split apart, and then the ribosomes would come and new amino acids would come and connect up, and then in the end you had two strands. And the whole thing was done by the marching band while they were playing music and marching around on a football field, and somebody took a movie of the whole thing. And we would show that to the students to explain how DNA replication worked back when it was brand new and nobody understood it. So yeah, I think there are artists working in every field. I just concentrated here on space art, but you could do an entire talk, I think, I'm sure, in biology or aeronautics or any field like that, because I think there are creative artists working in every field. And it would just depend on what they had an interest in creating, artistically or sketching or photographs or Photoshop, digital. Yes.
I just want to ask if you know, right? So, how did NASA manage to get so many artists to get interested in basically? Were you primarily by USS, or it's just more public that we get so many beautiful pictures from NASA? I would say mainly from like that. There was, yeah, it might be my business or ignorance, but I'm just checking. Did NASA do something deliberately to do this, or it just having more projects than they getting point out?
I suspect that NASA is very surprised that these photographs in this. Most of NASA's top brass couldn't care less, or at least in the 1960s and 70s and 80s couldn't care less. One of the big, as I'm sure you're all aware, considered one of the greatest failings of the moon of the Apollo program is the lack of continuity in interest in space exploration. And recently, I think that mistake has been understood, and some tiny portion, an infinitesimally small portion of the NASA budget, some manager who probably risked his job to budget a few $1,000s for a couple of artists to paint some pictures, could make all the difference to the next generation. And when your job is make sure that this pipe doesn't leak when it brings fuel from point A to point B, you're not exactly interested in budgeting for transport. Somebody somewhere, luckily, I think for us today here, was able to go against the tide and spend a little bit of money on this. It's funny, I'm sure many Egyptians throw away money on art when we could use that money to buy another. But this is one tired space shuttle, I'm sure, was more than the cost of all the art that I showed you.
Just to add a positive note, I think the space agencies which Congress get sidelined, like ESO, all of these also have started investing in something called artists in residence programs, and so are many other institutes who are now approaching outreach in a very good way. So they would have an artist stay in the institute or in the centers, interact with the people, and then find out ideas which would probably appeal commonly, and not then people would not say, why is the waste of money? It would lead to a common thing. And you'd notice that since we always handle these press releases and things which appear in public literature, somebody's attention is caught more by a visual than a headline or the science in it. So that's something I think it's very important to invest in the future.
So it has probably now occurred to many of you smart people to ask the question, where is the artist in residence at IUCAA? And so let's hope that in some time in the future, someone goes here and begins to document what you all do, these fantastic, amazing things that you do in a new and creative way that isn't necessarily a publication or a headline.
Thank you, Jonathan. It's just comment that back in 1950s, on every Friday, Homi Bhabha used to visit the studio where young artists used to gather. And sometimes we used to buy their painting for 5 rupees to 25 in that time, 5 to 25, which are topmost like Hussein and Guy Tonde, and whose painting now are running to millions of dollars. Same painting. And they are still there in titles. But they were bought for 5 rupees. Like, oh my God.
You see there are two murals in IUCAA, and there used to be many others. IUCAA came in.
Yeah,
We did have some.
the artwork, yeah, it's beautiful. I love looking at all the walls. You know, if somebody were to take a picture of a CCD controller, I'm sure it would look different than it does in a photograph, and maybe in a new and better way. Yes.
Nowadays, the high definition pictures and how much do you think paintings are relevant for inspiring younger students?
How are paintings?
It's because nowadays the artwork is moving and so those are more inspiring. So where do you think painting fits into the world?
Yeah, today it's true. Much of the art that's being created is digital art. It's created from the web or for some other reason that maybe everything gets printed or run on walls. To me, I hope that we continue to encourage artists to create real world art. We call it IRW, in the real world, the abbreviation, right? Because, you know, if, like I was thinking earlier today, if the Egyptians had only done their hieroglyphs on digital media, we would have no idea what they looked like. This stuff is ephemeral, and there's no way that you'll be able to read a USB drive 1,000 years from now. And if that's the only place your art exists, then, well, too bad. You know, we still got the Mona Lisa, and that's because it was painted on board, not done on a USB drive. So I hope there's still a balance of every kind of art, including music and art and physical art as well. Thanks.
Thank you, Fred. So, end of the session, we had a lovely series of pictures, and hope we stay in touch and you send us some more.
Happy to.
Thank you so much, Fred.
Thanks again for coming.
It was an excellent talk. It was an excellent talk. Thank you. Thank you.
It's not your average engineering talk.
Yeah, of course. Exactly. We also need to find the
reason for when the first landing happened.
Seems around 10 o'clock in the morning.
It's 160 questions. So long. Consistence, rocks on the wall, being once long. Right, yes. Come down. Oh, yeah, that's very difficult. Right, yeah, it's not impossible, right? Even a rock that could be 150 feet tall or something that one blaster could just land on and tip over the spacecraft. It had a limit, a certain angle that they could tolerate to take off, but greater than that, they would crash. So they had to land within about plus or minus 10 degrees of the vertical. But it wasn't very much. So landing it, every mission tried to land at 10 o'clock in the morning, just after like so. Yes, something about 20 days.
somewhere.
Nice long shot. Put that way. Right. They say to get into with the land as they came down. Right. And remember, they didn't, as they came in, most of the time they were firing the engine he said,
Yeah.
the astronauts were facing up in it wasn't until final phase when they pitched over, they were only several hundred feet above the ground.
Yeah, yeah.
And that's the first time they saw
What is going on?
everything else was like these total computers were right thing. It's all doing it with accelerometers. And,
Yeah.
and the first digital computer ever built. Nothing to meet to the moon.
Right.
Boy, better learn. Right. So, yeah.
So I was also impressed by people who drew this thing. They actually put in also the phase of the Earth.
Go ahead.
During the landing, right? That was quite impressive. So I think it's right on here.
Yeah, go ahead. You'll find it somewhere.
Yes.